Welcome back. Let's look at the relationship between arrays and pointers. So let's look at this first program which demonstrates how a pointer is linked to an array, right? So we have a pointer here which points to an integer. We have an integer array of 5 elements with elements 1000, 2000, 3000, 4000 and last element is 0. Right, so now we want to traverse the entire array. The easiest way to do it is ptr is equal to a, which is same as ptr is equal to ampersand a of 0. As we know, the base name of the array is same as the base address, right? Address of the base element. So now while star ptr not equal to 0, that is till we have not reached the last element, printf percentage d star ptr and then ptr plus plus, right? So let's look at this program. So here it's initialized now. ptr is pointing to the first element. Is it 0? No, it's printing. Now this is the most important point. ptr plus plus, right? Pointer is incremented. The value of pointer, let's assume it is pointing to 1000 now, address of 1000. When you do a plus plus, it will jump by size of integer because it's an integer pointer, right? So now if you look at it, it will jump by size of integer. So it automatically points to the next element. This is a very, very important concept. So now 4000, now it points to 0, star ptr is 0, the value is 0, so it comes out of the loop. So the most important concept here is ptr plus plus will increment the pointer not by 1 but by size of integer, right, which is very important. So the other thing to notice, this is a very easy way to traverse the array. You don't have to use the traditional for loop. You have another way through which you're directly jumping by size of int to the next element. So let's understand this program now. In star ptr, the same array is there. Now we are initializing ptr to a plus 3. So what do you think would happen here, right? It would actually take the base address of the array and jump by 3 into size of int. So it is here, it will jump once, twice and thrice. It will come here. If you see here, I executed, it is pointing here and you print the value, right? It prints 4000. Now let's change a bit and see what happens here. I will change, instead of integer, I'll change it to a character pointer. I'll change this to a character array and I'll change the values here as A, B, C and D, right? And here I leave the rest of it the same, right? So here probably I change this. Let's see what happens here. So in this particular case, we have a character pointer. We have a character array here, which has elements A, B, C, D and last is 0. ptr is A plus 3. Now let's see how it jumps. So here again it jumps to this element, the third index. So 0, 1, 2, 3. The most interesting part here is, given that it's a character array, it knows that it has to jump by 1 byte, right? It does not jump by 4 bytes. So the difference between an integer pointer and character pointer is an integer pointer jumps by size of int, which is usually 4. But a character pointer jumps by 1 byte, right? So when you do plus 3, it jumps base address plus 3 bytes. But if it's an integer, it jumps base address plus 3 into size of it. That is a big difference between integer and character pointers. So let's take the thought a little further forward, right? We have an integer pointer. We have a character array here with 6 elements, right? 1, 2, 3, 4, 5, 6, 6 elements. Now ptr, I'm making it point to the character array. So it's an integer pointer. I have typecasted it. So now it can point to a character array, right? And now I'm doing a ptr plus plus. What do you think would happen here? So it is pointing to A. If I do a ptr plus plus, will it point to B or will it jump by 1, 2, 3, 4? Will it point to E? Where would it point, right? So let's see what happens. Given that it's an integer pointer, right? So it initially points here. It is an integer pointer. When you do a ptr plus plus, an integer pointer always jumps by 4 bytes. It does not worry about where it is pointing to. It jumps by size of integer, so it jumps by 4 bytes. 1, 2, 3, 4. It points to E and E gets printed. So this is again one very interesting thing about how pointers work. So an integer pointer, always when it's incremented, it increments or it jumps by size of int. A character pointer on the other hand will jump by size of char. So let's look at this program. Char star ptr, character a of 6. We have 6 elements in the array initialized. Ptr is equal to a. It's a character pointer, so no typecasting is required. So here it points to the base address, right? Now what we are doing is star of ptr plus 3 equal to x. So what happens here? So ptr is the base address, so it's pointing to the base address of the array, plus 3, so it will jump by 1, 2, 3 into size of character because it's a character pointer. So 1, 2 and 3, it points to D now. So it's not changing the pointer, right? So we have not assigned it. So ptr plus 3 is this, and we are saying the value there is going to change by x. Pointer is still pointing here. We are not changing the position of the pointer. We are saying pointer plus 1, 2 and 3. The third position is equal to x. Let's see what happens. So this changes to x here. But the pointer still points here. Now if you print the pointer, it still prints a. But the value here has changed, right? So this is the way you can change. The pointer can remain at one place. You can change this here. Now the same thing can be done for integer pointers as well. So now a slight change to this. In star ptr and integer array, we are making the integer pointer point to the integer array. Ptr plus 3 equal to 99, right? So ptr is the base address here. So now let's actually move to this point. So it's pointing to the base address. Ptr plus 3 equal to 99. So what happens is it jumps by 3 into size of int. So this is 4 bytes, 8 bytes, 12 bytes. So 3 into size of int. So this 400 should become 99 now. Okay. But still the pointer is pointing to the first element. We have been able to change this. Now as I mentioned, there is a relationship between this notation. There is also another operator in C for a very similar thing. Let's look at that now. So let's look at this program. Again ptr, we have an integer array. We are making the ptr point here, right? So now we are changing the value of ptr plus 3 as 99, which is 1, 2, 3, 12 bytes later. So this value is getting changed to 99. Now we are using an array notation for a pointer. So what happens here, right? So ptr of 3, this is usually used to access an array element. Now we are using the same thing to access here. So this changes to 1 on 1, right? So basically this is same as this. There is no change, right? Now let's look at it the other way. I'm using this array notation, right? This is an array. Now I am actually using this pointer notation for this. Star of a plus 3 equal to 102. Let's see what happens. So this 101 now becomes 102. So let's look at this again. So here this notation is same as this. So a pointer can use either of these notations. Actually this translates to this, right? So that's what it means here. Again this is same as a of 3, right? So it is same as doing this. So these two are same. So if I give it as 102, these two statements essentially are the same. This is same as this. There is no difference. And this is same as. So this array and this notation and this notation and this are the same. So basically what this proves is array is internally a pointer, right? There is no difference. Only thing is it is a constant pointer. The base address of the array cannot be changed. So if you try to make a plus plus, it will not work. It will throw an error, right? So base address of the array cannot be changed, but array is same as any other pointer. Ptr can be incremented, But in case of array, it is again a pointer which has a memory allocated. It points to that memory, right? But the value of A or the address where A is pointing to cannot be changed. But all these notations can be interchangeably used. So for a pointer, you can use this notation. For an array, normally you use this. If you use this as well, it will work fine. So pointers and arrays, this is a very, very important concept. Pointers and arrays are very closely related to each other. So a pointer and array can be interchangeably used. Only thing is the array's base address cannot be changed. This is an error. So we saw array and pointers are pretty same, right? So now let's look at a program, right? Earlier we saw a program, right? Call by value and call by reference. So here let's take an array which has two elements where both are array of 0 is 0, array of 1 is 1, right? I'm calling swap with array's base address, right? A, right? So now I'm printing the value of A of 0 and A of 1 within the swap function. Now I'm receiving the array. I am making a swap. So temp is A of 0, A of 0 is A of 1, A of 1 is temp, right? So normally we saw that a call by value, right? If you have an integer variable here, it gets copied over here. And if you make a swap, whatever is the swap that happens here does not get reflected in the main program. But here it is a array, as you know, it's passing the base address here, right? So base address is received, so it's actually a pointer that you're seeing here. So the base address is received here. You're making the change and the change is reflected in the main program. So we started with 0 and 1. Now it has changed to 1 and 0. So in an array, if you pass an array to a function, whatever is the change made to the array in the function will be permanent or will be reflected in the main program, right? So it will be reflected. Remember that.